Okay, hey everybody. I'm Juan. I am the organizer of the DVT Meetup in the Netherlands. If any of you is somewhere one of these days, let me know. We're always looking for speakers. Uh, Thanks to some people from Hi-Fi Labs, I decided to come see how things are here and of course share with you one of the topics that I really like from DVT. To be honest, and many of you probably already noticed, I used ChatGPT to generate the title of the talk. And when I saw it some days ago, I just completely hate it, so I might have changed it a little bit. But what I wanted to do today is to share quite a lot of the options that you have in DVT to test your own code. Historically, SQL teams either didn't test their code or were horrendous at it. I'll never forget, probably one of the most mature data teams I worked for before DVT had a manual checklist of 20 items that we always had to check before sending any code to production. And I see some nodding heads, so probably like that's a shared trauma of many of you that have been working in the SQL space since before DVT. So let me show you some things, quite a lot of the options. Now, for those of you more experienced in this room, I can imagine that some of this is gonna feel obvious and repetitive. That's fine. I hope that I get to teach at least one thing. And I'm gonna do a massive no-no of presentations, which is cover all of my slides with code. So if you don't like code or whatever it is, don't worry, you don't need to read it. I will explain the concept. But if you're kind of a nerd, maybe you're gonna dig the code and I will make the slides available at the end. It all starts with a magic mean. Yes, I was wondering like how many people are gonna take a picture at this point. So these are, I don't know if this list is exhaustive and complete, but these are the type of tests that I see a lot in DVT. Some of them are more, let's call it natively supported and well documented. And some of them are a little bit of hacky, brilliant approaches. Let's start with the first one. Probably the first test that you get introduced when you work with DVT is called singular tests. And they're called like that because they are not reusable. They're meant for one use case, singular use case. Essentially what you do is you define in a SQL script, it has to be under the test subfolder in your DVT project. You just define some sort of SQL model. And if at least one row is returned, the test is gonna fail. In other words, you should type here something that should never happen if your code is correct. This sounds really nice and really cool, and probably many of you use it, but I have an interesting secret, and that is, even though I hate saying never, probably the more you work with DVT, the least you're gonna use singular tests. Why? Because after a while, you're gonna start thinking like, we should turn this into something more generic and reuse it. So it's nice, great to practice, and especially I think for documentation purposes is really nice, especially when you know there are more junior people in the code base. When they open this test, that's a really good hint of how the code is supposed to work more than anything. So I still advocate them more for a documentation purpose than like a serious data testing effort. The second type of test, and maybe as you are already noticing, I'm using the word test like very, very loosely. Just whatever type of feature that allows you to improve the code quality or the quality of your data is to test the freshness of your data. In DVT, you can very easily know if the data was properly refreshed by step one. Here inside of the YAML where you define your sources, you can also add some extra configuration under the freshness tag. And in there you can put all sorts of things from, I want every single table in this database to be this fresh as a minimum. You can add warnings, you can add failures, and you can even contradict that behavior even though it gets cumbersome. So for example here, all of the raw database has this default behavior, but we're explicitly overriding this for the orders table to behave slightly more strictly. So every 6 and 12 hours instead of 12 and 24. Once you have defined this, it's just a matter of typing dbt source freshness in your terminal, and it will tell you if your sources pass or not. This is an interesting approach, but the problem here is it's hard to know if this failing, it's very hard to know what exactly this means when the freshness is failing. Is it because you were too strict with a filter, so your fault? Or is it because somewhere, let's say in Fivetran or whatever it is, the data is not being updated? Or maybe the data was never meant to be updated as frequently as you stated. So they're nice tests, but to be honest, I personally never really use them because I don't know what to do with their output. But they're there. The third type of test, which is one of my favorites, is called generic test. This one is also very well documented by DBT. Essentially, once again, in the sources YAML, you can specify under the test tag some interesting things. By default, DBT comes with 4 generic tests, which are very similar to database constraints. They have unique, they have accepted values, they have non-null, and maybe the one that is a bit unusual is you can also specify the relationship. And this is for those database nerds in the audience. You're essentially testing for referential integrity. In other words, I want to do a join in this table, and every single ID is supposed to match. No ID is supposed to be left without a matching row. These are cool, and to be honest, like probably every single script should have them. It's documented as a good practice that always your IDs should have unique and not null. But this is, it really feels like not enough. Luckily, and this is where we're getting a bit deeper into like the whole data iceberg, you can define your own custom generic functions. As in other words, DBT comes by default with 4 of them, but you can create whatever it is that you want. For example, here, if you want to do it, it has to be under test / new folder called generic, and then you just create a SQL script that contains a macro. This one right here just shows you that it is possible to set them up as warnings directly inside of here, or it is fine to also set them up as failures. But what matters is you're not limited to those 4 options. The possibilities are really endless. They're up to your imagination. And it gets even better because there is no need to reinvent the wheel. If you're already excited about this, you should definitely check the DBT package hub, which is the library of like open source packages. In there, probably DBT expectations is gonna be very interesting if you like this idea. What DBT expectation does is it comes with, last time I counted like 60 something tests. So it sounds kind of weird, but 90% of the tests that you might think you want to write as custom test, DBT expectations already did it. I would also recommend you to check Audit Helper. I know it was mentioned during the last talk. And also check Project Evaluator, which have some elements that you could consider as tests. But DBT expectations is probably the most complete one. So chances are check there before you start making macros. The next level of the iceberg is something that is relatively new. I think this was only supported 9 months ago, something like that. So it is fine if many of you haven't like seen this. It's very well documented, but I know that some people were having issues testing this because it requires certain platforms, it requires a certain version. And so now it's become a little bit more available to everybody. Essentially what this is you can take a model. In this case, I have the very cliche email validation, which is a monstrosity of a regular expression, which, by the way, I think this doesn't catch like .co.uk. So it's a terrible, I really hope none of you has to validate emails. But essentially what you do is you have your model that does something, and then you create an additional file where you define test cases for that model. So you tell it essentially, hey, for this model I created, I think I call it my model, I should have been a bit more specific. If I give you these rows, this has to be the outcome. So essentially you can already be pessimistic in advance and think of all of the use cases that are gonna potentially break your code. And this is really cool because in the past, before these unit tests, we will write DVT tests. They would pass because no edge case has happened that breaks it. Time passes, 3-4 months, a year, then a weird edge case breaks everything, and by then you don't even remember how your code works. So it's already very nice to be defensive without having to wait for the data to be broken or to not meet some assumptions that you were expecting. To be honest, there is one thing I don't like about this approach, and that is I genuinely think unit tests shouldn't run at the model level, but rather at the macro level. Similar to how you would Ptest a function in Python, I really think you should localize only the test to a macro. You can still kind of do it, just open up a model that only contains a macro, or you can also, there are some packages that were created before this approach. You can check them. One of them is like DVT Ptest, which allow you to properly unit test your DVT macros. But I wish the official DVT solution would be a bit more self-contained rather than having to test something so big. But it's cool and it's kind of new. Next level is also something relatively new. Also, I think has been out for 9 months to a year, which is data contracts. They call them model contracts because they're a bit more general. So essentially, you're already documenting your models, ideally, in a YAML file. What changed is you can, of course, specify things like data type, some constraints like not null. But if you add this configuration, like contract enforce equal to true, which it's implicitly there in every single YAML, it's just that by default is false. But if you turn that to true, it is gonna fail if some of these are not correct. So this is really cool because you can literally sit down with your data owner and you can ask this person to make this list. Hopefully they're technical enough to write it as a YAML, but even if they do it in an Excel, is fine. But maybe the biggest life hack that I've learned is if you use this as a requirements list, as in like, I'm gonna build some DVT stuff for you, please let me know exactly what you want to see and how. It's awesome, you can use it as a data contract, and you also get a lot of clarity of how exactly people want their models to look like. So I really like this feature. Now reaching a bit deeper, another thing that I don't think is like very well documented. I checked the documentation of DVT last week. It is there, but I wish there would be a little bit more clarity on how to do this and how it's important. And that is having a CI pipeline. CI stands for continuous integration. It's essentially things that we would run to ensure that your code integrates into your existing code base without breaking anything. And I know DevOps purists are gonna kill me for this, but just simplifying all of that to data people. You just essentially use GitHub Actions to turn a computer, do some automated checks, and if they pass, put your code in there. What you're seeing here is indeed a GitHub Actions script, and this is probably like the most basic script that you can imagine. Just roughly, every time somebody tries to do a pull request to main, it turns on an Ubuntu machine, which, by the way, it's like GitHub does it. Their free tier is like super generous, so this is something that everybody can try in one of their pet projects or other clients without any cost, and that's something that you should definitely consider doing. You create a copy of the repository that you're working on. You install Python, install all of the dependencies, which mostly is just DBT and some of the packages. And then it's just as dumb as like install my DBT packages and do a DBT build. If the DBT build does not run for whatever reason, like, hey, your code hasn't been compiled properly or these tests are not passing, this is not gonna allow people to merge something into the main branch. And it's like the most stupid check ever. Like, check should be a bit more nuanced instead of like it passes or it doesn't. But I think this is the bare minimum. And I don't know if the people in the back can see this, sorry, but just for those of you that don't know, it is possible to just do a state modified, which allows your DBT build to only trigger on the things that have changed. And the little plus, which I'm 100% sure people in the back are not seeing, means everything that changed and all of the downstream dependencies. Let's just consider this the bare minimum, because in reality, you want to do a lot more inside of your CI pipeline. And then at the bottom of the iceberg, maybe even before, can I get a raise of hands to all of you that know what are DBT artifacts? Okay, that's a lot more people than what I expected. Is there somebody here that can tell me at least the names of 4 of those artifacts? Somebody theirs? I didn't hear, but it sounds correct. Yeah, well, I think there are 5. There is one that triggers when you do the source refreshing, which I don't think people know that one because it's so rare. But yes, you work for Hi-Fi Labs, right? I was planning to use this as to give somebody a present in the audience, but I realized that I already gave one to Hi-Fi Labs, so we're gonna do it another way in a moment. Okay, let's go to the latest level, which is indeed related to the DBT artifacts. What you need to know is that every time you do any DBT thing from your command line, from a DBT compile, DBT run, DBT build, DBT test, and even DBT source freshness, I'm probably forgetting some of these commands, DBT creates quite a lot of artifacts. So just, yeah, basically they're JSON files, and it puts them under the target directory. Now, the target directory is by default hidden, but probably if you're using DBT core, you probably have seen it. For those of you, that's essentially where DBT puts all of the files that it needs to run. Some interesting things that you will find there is the compile code. So exactly what DBT sends to a database. Yeah, compile SQL files, but also all of these files, and you can see later how they're generated, that give DBT some information. What is really cool, if you ever have like a free 7 days of time, make sure to open them and explore all of the information that you can find in those JSON files. You're gonna notice there is like a compiled version of every single piece of documentation that you have written as a YAML. some information about your code, some information about your run, which is quite interesting, like how long models take, when were they triggered, if they fail, by whom, all sorts of metadata that is interesting. Probably more mature DBT teams are either saving these files every time there is a run somewhere in a storage bucket, or at least creating logs or ingesting some of it as a table. Why? Because this information is not easily available or not fully available from DBT Cloud, but it gives you a lot of clues on how it's going with your deployment. From who's the worst coder to which are the models that perform the worst, and probably which models you should prioritize when you're refactoring, or which ones tend to fail more often, and so on. So yes, definitely play with this, check them out, and explore all sorts of interesting info that you can find there. But what is interesting, and this is something that I learned from a colleague of mine, you can find in the sources his GitHub. He has a repository where he has like hundreds of examples. I just picked the easiest one to fit into one slide, but please check it out at the end. Essentially what the guy does is it creates a DBT fixture based on those files. Essentially, just simple terms, it opens them with Python because they're really just JSON files full of information. And then he uses Ptest to test all sorts of interesting things. For example, he has a Ptest that if a model takes more than so much to run, it's not even going to merge it. A Ptest that if the number of rows is less than the previous time, is not going to merge it. Or this one that I think is quite interesting is, depending on a regular expression, it's going to check all of the column names and either pass them or fail them. This one is really just strict that the column name should be alphanumeric or underscores and all in lowercase. But in reality, I think it takes it one step forward. Like, if the column is type date, it should contain the word underscore at the end of the name. And underscore date. And if it's a date time, it should contain the word underscore at the end. Which it's a level of strict that you can actually do if you're really good at parsing stuff with JSON. Or if you pass the JSON to ChatGPT and tell it, give me a query to get this specific part. So just to recap, DBT has brought a lot of ways in which we can test our code. And this is interesting because historically, this is something that software engineers do super well. They even laugh about how primitive some of DBT's ways of testing are. But this is something that didn't used to happen too much or at all. I never really saw a really good testing suite before DBT in a SQL workflow. So it is fine if you were not very familiar, but for the sake of the trust that, the trust that your data users put in you, it is a really good idea to test. And not only that, like I mentioned, to me, the most compelling argument for test is their really good documentation. Every time I open a DBT project, I like to read the test because it gives you an indication of how the developers expect the code to behave. Sometimes it doesn't behave like it should, but at least I know how they expect it. Last thing that I wanted to leave you all with is, in the world of DBT tests, there is something very important, and that is a test failing could mean one or two things. And it's super important that you know which of the two. It either means that your code is wrong, you messed up, or it means that the assumptions of the data are not correct. Maybe they told you the data was going until started at 2018, and then you find a row that is 2017. Well, maybe that's fine. That's just somebody told you the data behaved in a way and that was incorrect. it's super important that every time you do test, you're very clear to yourself which of these two are you trying to figure out. And the reason why I put the your code is wrong under the magic castle is because if you fucked it up, that's fine because you can easily fix it. If there is a problem with your data, it's a nightmare to fix. So I really hope that you're the problem. Once again, I'm leaving these slides. If you want to copy the code, that's more than fine. But 3 resources I wanted to tell you all. This repository, DBT Beyond the Basics, is done by a colleague of mine. It has a lot of interesting examples of things that you should consider doing once you reach a certain maturity level in DBT. It has quite a lot of examples of CI, but it also has examples of orchestrations, of CD pipelines, of just check it out, get some ideas. It's really more of a sampler of all of the things you could be doing. The next one is a DBT repo by Bruno de Lima. He has also some examples of how you can create your own CI/CD pipelines. The one you saw in my slide is the most basic one possible. That's what it would fit. But in reality, you want your CI/CD pipelines to do much more, like to save your artifact somewhere or to automatically test or God knows what. And you should also follow this guy. He posts DBT content every day on LinkedIn. And he actually knows more than the people that post on LinkedIn regularly. So check him out. And finally, Datavault, which I know you mentioned also briefly. They have an article on best practices for testing. I think the article is maybe a year old because it doesn't contain a unit test or something. But it is still a really good guideline for the people that want to see how to test on DBT and just have a nice read. And finally, if you enjoyed this conversation, I have 3 invitations for you. The first one is connect with me on LinkedIn. Let's talk about you guys coming to a DBT meetup in Amsterdam. That's more than fine. The second is I recently started a podcast. It is just 1-hour conversations with data people. I'm trying my best to make it for a more mature data audience. That sounds weird. But yes, essentially no hand-holding. You don't need to explain what ETL stands for every single episode. So I hope that you enjoyed it. And if you're in the Netherlands, also let me know. Happy to record an episode. And finally, recently, some colleagues and I released a book. It is essentially 14 chapters, and each chapter contains one thing that we consider a critical skill for analytics engineers. So there is one chapter on data transformations, one chapter in data modeling, one chapter in data governance, one chapter in ingestion, and so on. It is perfect for those of you that are either transitioning from data engineering to analytics engineering or analyst to analytics engineering as well. Just to make sure that you have no gaps in your knowledge, at least at the basic level, it's still like an introductory book. I actually have a copy that I wanted to give, and I was going to give it to the person that told me the most DBT artifacts, but I already gave Hi-Fi Labs a copy, which you can expect tomorrow in your library. So maybe let's do something with the rest of the audience. The very cliche interview question that I've used to give this book is there somebody that can tell me the difference between indexes, clustering, and partitions? Somebody there? To be honest, clustering, I meant it more in the context of databases more than data science. But you know what? You got the other two correct. So I mean, to be fair, the words clustering, the words model means so many things, even for us data people, that doesn't matter. Yeah, I hope you enjoy it. Good. And with that said, thank you so much for paying attention. I hope you enjoyed it and at least learned one thing, especially those of you that are DBT gurus in this room.